Okay, so when ax squared plus bx plus c is our general form for a quadratic, when that leading coefficient, is not the GCF, there are two ways that you can do it. Okay, you can do kind of trial and error, or you can use the slip, divide, and slide method. I don't know if you've ever seen that before, but I'm going to show you how to do it both ways. Some people prefer one method, some people prefer the other method. So this is how I learned how to do these problems. Okay, I put my two sets of parentheses. Okay, I know I checked to see 28 is not divisible by 3. Okay, neither is 55. So 3 is not our GCF, so we're out of luck there. So instead of automatically, I can't just put b and b, because that just gives me b squared. I'm supposed to have 3b squared. So I've got to figure out, okay, well, what multiplies to give me 3b squared? Well, that's 3b times b. 3b times b gives me 3b squared. Now, I got to look at factors of 55 that multiply to give me 55, and they're going to add to give me 28, but it's not the numbers themselves that are going to add to give me 28. What I mean by that is that 28, that term in the middle, is a result of adding the outside multiplication and the inside multiplication. So notice when I multiply these outside numbers, one of them is getting multiplied by 3. Okay, so what's the most common factor of 55 that you can think of? 5 and 11, right? Okay, well, 5 and 11 obviously don't add to give us 28, but when I put them in like this, the outside gives me 33, and the inside gives me 5b. 55 was negative, so that means I have opposite signs. I need to get positive 28, so that means my 33 needs to be positive and my 5 needs to be negative. Now, I've been factoring for a really, really long time, so I know kind of how the pieces work together. That one was pretty easy for me. That's going to take a little bit of time, a little bit of trial and error. Let me show you the slip, divide, and slide method that some of you may find a little bit easier. We're going to factor the same problem. We're going to get the same answer, but I'm going to show you a different way to get there. Okay? So the first part is you slip. So you take this first coefficient right here, you slip it to the back, and you're going to multiply. So now our problem becomes b squared plus 28b minus, I think that's like 165 or so. But let me make sure, 55 times 3. Yeah, 165. Okay, so now we've turned this into a problem where a, our leading coefficient, is 1. So we're doing what we've just been doing. I can automatically go ahead and write down b and b. I can say I have, my last sign is a negative, so that means I have opposite signs. So I got a plus and a minus. And now I've just got to play with the factors of 165 that add to give me 28 when they have opposite signs. Okay, so factors of 165 that add to give me 28. Well, I'm going to have to use my calculator a little bit. I know it's divisible by 5. Okay, if it's divisible by 5, I get 33. Well, if 33 is positive and 5 is negative, 33 minus 5 is 28. Okay, we're not done though. Okay, we've only done the slip and the factor part. Now we've got to divide. We divide these two numbers here by what we slipped. So we slipped the 3, so we divide both of these by 3. Okay, so 33 is evenly divisible by 3, so that's good. We just reduce that. Okay, 33 divided by 3 is 11. 5 is not evenly divisible by 3, and we can't reduce it either. Okay, 5 over 3 is fully reduced. You can type it in your calculator. Type it in, 5 over 3, math, enter, enter. Turn it into a fraction. It will give you the fully reduced fraction. So 5/3 is the fully reduced version. So here's the last part, the slide, because that doesn't reduce, the 3 slides in front of that factor. So there's the same answer. I've just got them in different order, okay, but it's the exact same answer. B plus 11, 3b minus 5. So there are more steps to this, but there's a little bit less trial and error that you have to worry about, okay? The first way I showed you, you may have to sit there and you may have to erase some stuff a few times until you get the right combination of numbers. This way, you don't have to worry so much about the combinations. You can just use those rules that we've been using, okay? Do y'all want to see another example with the slip, slide, and divide? Do y'all want to see another one? Yes or no? Yes? Okay. So let's look at, that was number 13, then let's look at number 14. We'll do number 14 that way as well. Okay, I'm not going to do it the original way. I'm just going to show you the slip, divide, and slide way. Okay, so 7x squared plus 53x minus 90. Okay, so we start by slipping. The 7 comes back here to the end, and we're going to multiply. Okay, so the 7 comes to the end, we're going to multiply. Here's what our problem looks like now. X squared plus 53x minus 630. Okay, this is kind of the downfall to the slip, divide, and slide method. Your numbers get a little big sometimes. All right, so 630, well, the easy, obvious one is it ends in 0, so it's divisible by 10. Okay. So it's divisible by 10. When we divide by 10, we get 63. Well, we lucked out. 63 and 10, we're supposed to have opposite signs. Those are going to add to give us 53. So we can go ahead and factor this. X, 63, 10. They have opposite signs. The bigger number is positive. So the 63 is positive. The 10 is negative. 63 minus 10 is 53. Okay, now let's divide. Okay, so that was the slip and the factor. Now we've got to divide. We divide by that number that was in front. We divide by A. 63 is evenly divisible by 7. Okay, 63 divided by 7 is 9. 10 is not divisible by 7, and 10 over 7 is fully reduced. So then we slide that, 7x minus 10, and that is our answer, and we can check it. Boil it out real quick. X times 7x is 7x squared. X times negative 10 is negative 10x. 9 times 7x is positive 63x. 9 times negative 10 is negative 90. That is what we had originally. Okay, 7x squared plus 53x minus 90 was our original problem. Okay, so some people think that's easier. Some people think the trial and error is easier. I don't care which method you use, as long as you can factor things like this.